Hi, today we will learn refraction through lenses. Now question is, what the lenses are? So people wear specs and the specs have glasses. These glasses are actually lenses. Have you ever noticed that these glasses are not plain? These transparent glasses are a little bit, curved one. So these are called lenses. Here you have one concave surface and other surface. From outside it is convex. So this lens is termed as concave convex lens. And in this way you have so many kind of lenses. Suppose your first surface is convex and another is concave, so name is changed. In this case you will write for first surface you will be writing convex, for second surface you will be writing concave lens. So what a lens is? A lens is bounded by two surfaces. Lens is any transparent material medium. And it is bounded by two surfaces. At least one of which, out of the two surfaces, at least one of which must be spherical, so this is a lens and we have to learn refraction through lenses. So let me take this kind of lens first of all, this kind of lens, and you can see that both the surfaces are convex. So you can name it as double convex lens. So let us start our learning of how the rays are refracted by taking this double convex lens. So let me take first of all its first surface. This is a part of a sphere, so it would have some center of curvature. It would have some this in lenses you have not poles, you have optical center. You have in lenses all those things, all those glasses that are worn in our specs, and this is transparent from both the sides. It is not opaque. And in transparent material medium, which we term as lenses, they have optical center. Instead of pole, they have optical. And if you draw a line through this optical center and center of curvature, then this line is termed as principal axis. And in between optical center and C, mainly at the center of these 2 points, you have a point that is called focus. So I'll explain all these things, but firstly we see how the images are formed. Suppose you have one object here, AB object. So when a ray falls on this surface which is separating the two mediums, you can see, and obviously the second medium is denser one and the first medium is rarer one. Okay, so now it will be bending towards principal, towards normal, as it is going from rare to denser medium, and according to rules of refraction, this ray will be bending towards normal. So let me draw first of all the normal. This is a normal ray, a ray which is passing through center of curvature at the point of incidence is called normal. Any radius is normal actually. At the surface which is in tangent direction at this point is perpendicular to the radial direction. Here you can find a 90-degree angle. So this radius which is initiated from this point and which goes up to center of curvature, this line is called normal. So when a ray goes inside from rare medium to denser medium, it does not continue in its initial path, rather it bends towards normal. So this happens on the first surface. Now let us take the second surface in second diagram. Here I am taking second diagram, and from the first diagram we see that a ray is going along this direction. I am just taking a line parallel to this one. So on second surface the ray is falling in this way. Now again we will be finding the center of this part of the sphere, and let the center of curvature be here. Now let us take optical center and nearly half of it as focus, and let us draw the same principal axis for the second surface too. Here you have principal axis. So the same rules of refraction. When light goes from denser medium, now this lens medium is now denser one, and the ray is going from denser to rarer. Here the ray goes from denser to rarer, so it will bend. Now which way it will be bending? For that we need a normal ray. Here we have a normal ray. Okay. A ray at the point of incidence which is along radial direction. This ray is called normal at this point of incidence. So when the ray goes from denser to rare medium, it does not go along straight path. Rather, now as it is going from denser to rare medium, it will deviate away from normal. As per second rule, as per that rule, the ray will not go straight path, it will deviate away. So when you combine the two figures, then you find that I am combining, okay, let me delete this, let me take a proper curved, okay, a curved surface, the halfway of which is your principal axis. Here you have principal axis. When you combine the two surfaces, the surface first one and the surface, here you have first surface, here you have second surface, and when you combine and when you take the same object AB, then you observe that in both the cases, in first case also it is bending towards this principal axis, and in refraction through second surface also it is bending towards principal axis only. It is not going straight path, it bends towards principal axis. So you see that ray is bending in both the two refractions at two surfaces just along the principal axis, along downward direction. All such lenses which bends the ray towards principal axis are called converging lens. Are the lens which converge the rays towards, let me delete, towards principal axis. And there I am giving some example. All the lenses, all the transparent mediums bounded by at least one spherical surface. Those are called lenses. Now, if the second surface is convex, in this very case you have second surface convex, here you have first surface concave, but again your second surface is convex. In this very case you have first surface plane but second surface again convex. In all the cases when ray falls it will bend towards principal axis. It bend towards downward direction, towards principal axis only. In this case also the ray will bend towards principal axis. So such lenses are called converging lenses. Now let us name all these lenses, and as per the shape of their surfaces you can name very easily. This is double convex lens, and this is your concave convex. Lens, also called, since it is converging, so it is also called converging meniscus. Now you have this lens, and you can name this lens also as per its shape of its surface, the two surfaces. So you can say it plano, convex lens. So all these are your converging lenses. I am discussing here the kind of lenses. Now diverging lenses. Now let me take the two surfaces concave only. Two surfaces concave. And let us try how the ray which falls on this kind of lens, how it is deviated, how it is bent. So let me take first of all, and yes, it has two surfaces concave, so you can say double concave lens. Okay. Now the first surface is concave, and you know that the first medium here, the medium is air, which is rarer, and the second medium is denser. Okay. So now do all those things for finding how the ray will be bending. So let me take first of all principal axis. Here you have center of curvature, here optical center, and midway somewhere there you will have a focus. Now when a ray of light goes from rarer medium to denser medium, and it falls on surface here, and here you have point of incidence. So let me draw a normal. Normal is a line along radial direction at the point of incidence. This is your normal. This is your normal. So you know that when ray of light goes from rare medium to denser medium, it always bends towards normal. Here you have normal, and we will now not go this way. We will bend little bit towards normal in this way. So this is your first bending from the first surface. Now let us do with second surface. So if this is your second surface and ray is falling, okay, ray is falling in this direction. So let me take that ray on the second surface. Okay. And in the same way, let me draw principal axis. Let me take a point called center of curvature, another point optical center, and then midway there we have a point that we can call focus. So at the point of incidence, if you try to have normal, so let me draw a line through radial direction, and this you can say normal. And now the ray is going, since lens is your denser medium, lens is a denser medium, so in this very case the ray is going from denser to rare. Here you have denser, and second second medium in this case for this surface is rare, right? So when ray go, it will not go straight away. In rare medium, as per rule of refraction, you have the ray bending away from the normal. So you can see in both the cases, in first case as well as in second case, the ray is bent away from this principal axis. So when you combine the two surfaces and draw the principal axis, you find that the ray is bending away in both the cases. Ray is bending away, sorry. Here I should draw a concave surface only. Okay. So here you have a concave and here you have a concave surface. So from this we can see that the ray is going away from principal axis. Such kind of lenses are called diverging lenses. The lens in which the rays of light after refraction goes away from principal axis. Then such lenses are called diverging lenses. And we can have so many diverging lenses. Let me give examples. And this example also you will see that all the lenses with the second surface concave one. Here you have second surface concave one. So, and as per the shape of surfaces, you can name this lens as double concave lens. Okay. This is first example. Second example is again you should take second surface as concave one, and first surface you can take even plane also. So this will also diverge the ray of light away from principal axis. So this lens is called as per the name of its surfaces. You can write its name plano concave lens. And third example is, again you will see the second surface is concave one and here first surface is convex one. So you can name it convex concave lens or diverging meniscus. So these are the kind of lenses. Now let us learn the terminologies that are used while doing with lenses. So let me start with the definitions that we use while doing with lens. So here you have a convex lens, and this is a line which you will be saying principal axis. The center of this point is called optical center. Okay, and it is having two center of curvature. This is your first C1, and here you have, if you produce this surface, you will be getting the center of the surface. Here you have C2. So you could see that you have two centers of the two surfaces. Okay. Now let me define all these terms. First one is center of curvature. So it is the center of that sphere which is forming the part of a given lens. Is the center of the sphere let me write sphere only. This sphere is forming the part of this very lens. So you can write which is forming the part of the lens given. Okay. So this way you will be defining center of curvature. Now next point is optical center. Okay. So when you throw light on this lens at all the points, you will find that the ray is bending. The ray is bending towards principal axis. If you throw light from a laser torch, you will find that it is bending towards a central line. But if you throw a light through this central point, which I am calling optical center, the ray passes undeviated. It does not bend. So optical center is a point on a lens on which if a ray of light falls, if a ray of light it passes undeviated without being bent. Okay. So we define principal axis, center of curvature, and this optical center. Now focus, the important one. Now let me draw again the ray diagram of a lens. So you will find that all the parallel rays which are very close to principal axis, they are also called paraxial ray or coaxial rays. After refraction, they will be passing through a single point. And that point is called focus, and this point is called principal focus. Now you have two focus, so this one is principal focus. So what is focus? Focus is a point. Okay, let me write focus. So focus is a point on principal axis. So okay, let me take an example of one more lens, concave lens. Now if the parallel ray falls on this lens and they diverge, you know concave lens diverges the ray away from principal axis. Now they cannot meet at any point. So when you produce these diverging rays along backward direction, then you will find that it appears that if you place your eye here, the ray will be appearing to come from a point, and that point we call focus. So focus is a point at which all the parallel ray either meet in case of convex lens or appear to come from in case of a concave lens. So let me write focus. Focus is a point on principal axis at which all the parallel rays paraxial or coaxial rays either meet. In case of convex lens, you can see, or appear to come from and this is in case of concave lens. After refraction, and you will find that this focus, here is a point focus, here is a point focus, then you will find that, and focal length. Let us first of all define focal length also. Focal length, the distance between from optical center to focus, from here to here, this distance, this is called focal length. In concave lens you can see from optical center to focus, this length is called focal length. So focal length, which you can represent with small f, so the distance between the focus capital F and optical center is called focal length. Now okay, you have defined so many terms. Now aperture of lens and focal plane. Focal plane. Now here you have a lens and the ray are meeting or passing through this very point. This point I am telling focus. So if you draw a plane passing through focus and perpendicular to principal axis, here you have principal axis and here you have focal plane. So focal plane is a plane that is passing through focus and it is perpendicular to principal axis. Plane is a plane which passes through focus and is perpendicular to principal axis. Okay. And now, last but not the least, aperture of lens. The size of a lens or diameter of lens is called its aperture. Of a lens, okay, of a lens is called its aperture. Okay, so these are the terminologies which we will be using while doing numericals or other things or while learning the concept of lenses. Now, ray diagram for formation of images with the help of lenses. Ray diagram for the formation of images. Through lenses. So again, I'd like to tell you that from a single point you have infinite lines coming outside, emerging, emanating from a single point source. We have infinite range from a single source of light, and we do not know which way these rays will be bending. So for each time, we will have to find using formula or see which way the ray is moving. So it is very difficult to do with all these rays. So better this take some helping rays. Out of all these rays we have 3 helping rays. Why helping? As we know from before that if they are incident on a lens, then after incident they will go through some particular direction. So let me write the 3 helping rays. First one, parallel ray. After refraction through lens, will pass through focus. Okay, one thing was left, let me explain again. Here we were doing focus. So, okay, we did focus, okay. And the parallel ray meet at a point. This focus is called principal focus, okay. This focus is called principal focus. And if you have, okay, this was left, let me complete over here. This was left. So let me take one more lens. Let me draw one more lens here. Now you have a point from where if rays initiate and incident on a lens, after refraction they will become parallel. So this is the case just opposite to this case. Parallel ray meeting at a point, and that point you are calling principal focus. And now in second case you have a point on principal axis only, and from where if rays are initiating after refraction they will become parallel to principal axis. So this is also called as focus, termed as focus, and this is actually F2, second focus. This is your f2. So do recall that you have two focus, principal focus f1, and here you have focus f2. Okay. So let me come on the point. So we have three helping rays. Parallel ray after refraction through a lens will pass through focus. Will pass or appear to pass. Okay. So let me delete this. Will pass or appear to pass or come from focus. Now second helping rays. Again from focus will become parallel. From focus will become parallel after refraction through a lens. This is second helping ray. So you need not to obtain in different cases of your different rays. There are so many rays are initiating from a single point. So we do not know which way these rays will be going after refraction through lenses, but we are knowing that these three helping rays that I am writing, they will go along a particular direction as mentioned in all these 3 points. So third helping ray, a ray passing through optical center. Will pass undeviated. So these are the three helping rays. Now let us make a one ray diagram for the formation of image. Okay. For the formation of an image when image through a convex lens, when object is placed beyond center of curvature. Case 1, when object is placed beyond center of curvature. Okay, so let me draw. So first of all, let me take a lens only. Here I have a lens. So let me produce the two surfaces so that we could exactly get center of it. So this is your C1, and if you produce this surface, you will be getting its center. Call this center as C2, and then pass a line through these two points, and you will be having principal axis. So after doing these things, now take any object beyond C. Here you have C, and beyond C you are taking an object AB. And we know we have three helping rays. We have three helping rays. Let me take object smaller one. So a ray which is parallel to principal axis. Now after refraction, here you have optical center. Okay, let me write. Here you have F1 and here you have F2. So better we should write here C1 and C2. So a parallel ray which incident on the surface of a lens, after refraction it will be passing through this focus. This is one ray. Now let me take another ray. I am taking a ray which is going through optical center, and look, it is passing undeviated without getting bent. And we get a meeting point over here. So here you have image of this object AB, and call this image as A dash B dash. So now this is the ray diagram. Now nature of image. You can see that when object is beyond center of curvature, then it is forming in between C and F, and the rays are actually meeting. So rays are actually meeting, so real image. Rays are actually meeting. So in this case, the image forming is real one, and you can see that it is inverted also. So real images are invariably inverted also with respect to object. Now it is forming, you can see when object is beyond C, then image is forming in between C and F, forming between C and F. And last but not the least, you can see it could be clearly visible also that object height is greater than image height, means smaller image, size of image diminished image means smaller image. So this is all about how you will be making image through any lens. So now here I conclude